genomics actually unites us all. And us in this context would be Monash, the world, and whatnot. Okay, animals, if you look at the bones of our hand, we share a lot of similarity. You know, everybody has this thing. Maybe you got a little bit of difference here and there, but still, we are similar. It's a little bit different from time to time. And in the next slide, there we go. I matched them all. Garfield, slightly different, you know. The whale, still have that 5 fingers, but it's a little bit different too. What I'm trying to say here is that underneath it all, we share something in common. And this is something that genomics is really good at as well. Because you take your cell apart, break it down, you get something we call DNA. And guess what? Everybody of us, each of us, all humans, must have DNA. That makes us who we are. That makes us living organisms, pretty much. Then the question now is, what is DNA actually? So in English, you have 26 letters. Computer science, you got I-O, binary. In us, the language of life, O, A, T, C, and G. Different combination makes you you. My combination makes me who I am. And that's what we call the language of life. Genomics is the study of genome. And genome is the entirety of the DNA. All the DNA you can have become like a storybook. I have my own story. A dog will have its own story. Everybody has its own story. How complicated it is depends on who we are, what we're doing, pretty much. And human, we celebrated the publication of our story in 2001. Very interesting study. 2 big boys in the world of human genome. Publication happens around the same time. They don't like to work together, so they publish this guy publishes his one, he publishes his one. But in general, we're very big. Our genome is 3 gigabases, it's huge. What's the purpose of doing human genome? Well, first thing first, I can do personalized medicine. Based on my genome, I eat the best drug for my disease. I can try to trace who killed my family, whatnot, because I have my human genome. And the problem though, is that when you have a human genome, it's really expensive to sequence it back in those days. A lot of money has to be invested to do just one genome. So how? You want to study everybody, but it's so expensive. It's not practical. And the good thing is, a company called Illumina actually comes up with a machine, and as you can see, when they comes out, they reduce the price of human genome dramatically. And I try to map myself along this genomics revolution. When I was young, I was here. Got my PhD, getting there. It's getting cheap now. And when I joined Monash, oh, thank goodness. It's so cheap to sequence human genome or genome in general right now that we, Monash, takes the first initiative to come up with an arowana genome. We think that is one of the most important things to do for Malaysia because number one is this has been hunted to extinction. It's really it's really expensive, this fish. And from an evolutionary point of view, it's very interesting as well. So we choose to do that, that's our debut in genomics pretty much, in Monash, Malaysia, the first. And so people will be like, okay, you sequence the arowana genome, so what's next? The thing is, if you look at all these things, they're all arowana. Look different though. You got this nice pattern, hunchback, albino, or this thing is really expensive. 40,000 ringgit just to get one fish like this. The question now is, what makes them different? With a genome, you can look at things like this. Look at what the color variation, what genes dictates what makes it different. And the nice thing about genomics is you can unite everybody. You can sequence the dengue genome, Dr. Sharifah, Sadiq, with the rice, Chris, crayfish, me, I'm a microbiologist. So anything with DNA, you can sequence it as well. The problem though, is that when you have so much genome, you can sequence 100 genomes, no problem, but with great power comes great responsibility. I can't publish 100 papers in a day or in a year, that's insane. The genome has so many things to tell. You gotta find the best story to tell and publish it. It's not easy. And on top of that, you got another small, tiny problem. If the genome is so big, you're gonna be dealing with a lot of data set, a lot of A, T, C, and G, a lot of it. So it becomes a pain actually. And us, we can't deal with that. So it becomes a problem. But luckily, I think early this year, Monash University Malaysia invested in something we call the HPC. So this is a very rare opportunity whereby two infrastructure is working together to come up with a better thing. We help HPC to put all those nice bioinformatic biology software that allows us to analyze genome more efficiently. And we hope that in the time to come, it will be very nice infrastructure. On top of that, you have the machine, not even the people to do it. The genomics facility only have 5 people, so we tap on the capacity of undergrad students. Young minds, all good. People tend to ask me, is it really okay? It's so early for genomics, it's such a new field. But I say, no, they can do it. And guess what? Just late last year, I think, we got a publication, two publications. First year undergrad student, just so you know. We got that. So I'm just saying that it's never too early to do research, especially in genomics. And on top of that, I believe when you know stuff, you shouldn't bring it into your graveyard. You need to tell the world, you need to tell the students. And most importantly, you want to ignite their passion. So that's what I'm trying to do with undergrad students right now. And this is really important because that is unity. You bring students together with genomics as the field. And last but not least, even within the genomics facility, I have unity between different biology. I got fish, I got plants, and I got bacteria working together to make this sustainable system. We have it in our lab. This is in our lab. It's a picture in our lab. This is me showing undergrad students what's going on. So, in summary, I think genomics is a really fun field. It brings people together from different levels, among students, among researchers, and well, we're here to stay, and I hope we get more interesting things done in the near future in Monash. So thank you very much.